Hey guys, so we're going to be looking at composite functions, right? Now, the first thing you need to understand is that a function can be denoted as some function of x. Not all functions are functions of x, so let me just keep reminding you of this. It is just that most often we use x as our input, so we may say h of x, g of x, f of x. Notice that all these functions have a different statement. So where h of x is 2 times x minus 3, g of x is 4 times x plus 1, and f of x is represented by x squared plus 2. Now, when it comes on to a composite function, what we're saying is that we're going to be putting a function into another function, just as how we would have done a substitution of a particular value of x. So given the function h of g of x, and this is how we read this, h of g of x. Now what this means is that in your h function, we're starting with the h function. I'm going to look for the h function and see what does it say. So if you have not watched the video as yet on evaluating a function at a point, it's very important that you do so that you can better understand what it means to do the composite of a function. Now we're starting with the h function. I'm going to record what does the h function say. It is 2 times the x value minus 3. I wanted to take note that I did not put a value here. Why? Because inside the h function, instead of putting x, I should put the value, the function g of x. So notice I wrote down everything except what x was, because that is what I'm going to replace. What am I replacing it with? The g function. What did the g function say? The g function said 4x plus 1. So inside this function, I'm going to put 4x plus 1. Now, when you evaluate or write the composition of a function, you're then required to simplify whatever expression you get. So here I have 2 was originally multiplying x. Now what is 2 multiplying? 2 is multiplying the entire g function. It's because the g function replaced x. So it therefore means that I'm going to be doing an expansion of the bracket. So now I need to remember, what does it mean to expand? 2 will multiply 4x first, which will give me 8x. 2 will also multiply the 1, so 2 times 1, that will give me 2. I need to remember there was a minus 3 outside the bracket. That was a part of the original expression, so I put it back. Now I can still do some further simplification, because positive 2 minus 3 can be simplified since these are like terms. And so I'll get 8x. Notice I did not do anything with the 8x because this term is not alike as these two. This has x on it and these terms does not. When you take 3 from 2, you will get a negative 1 because 3 is bigger than 2. This is now in its simplest form because 8x and 1 are not like terms, because this is a variable and this is a constant here. So the function g of h of x would have been 8x minus 1. You could have been even asked to further do something else. And how does one stem into the other? What if you got h of g of, let's say, 2? What does that mean? Now we already know what h of g of x is. That is 8x minus 1. If I was given h of g of 2, it therefore means that where x was, I'm asked to put the number 2. So whilst this expression could not be simplified any further, the expression of h of g of 2 would mean inside the function h of g of x, which is 8x minus 1, I should replace the x value with 2. So that becomes 8 times 2 minus 1. 2 times 8 is 16 minus 1, and that gives me a value of 15. That means that h of g of 2 is the number 15. Now, let's look at something that might be a little bit more complex. What if you're asked for g of f of x? Now, just as how we would have done the one before, we're starting with the g function. The g function says 4 times x plus 1. So I'm writing down 4 times some value of x plus 1. Now, notice I did not write x because I'm going to be replacing x with the f function. I'm coming up here I'm looking for the f function. The f function says x squared plus 1. So when I come down here, I should put in x squared plus 1. Now I'm going to go ahead and I'm going to expand in order to simplify. So the 4 will multiply x squared. What does that give me? 4x squared. The 4 will also multiply the 1, and that gives us 4 plus 1. I will simplify the expression here. So this is 4x squared plus 5. I think that was pretty simple. But sometimes what we do is that when we see terms that are not standard linear but quadratic, we tend to become frightened. But let's not be frightened by any of these things, because we're doing a simple step-by-step approach, one step at a time. Now let's go a little more further. What if I had given you the expression f of g of x? Look at the expression here versus the expression here. This one starts with g and we put f inside of g. This one starts with f and we're putting g inside of f. Let's see if that makes any difference. Let's come up here. Remember what the functions were. Now inside I'm starting with the f function now. So here's my f function, and what does it say? The f function says x squared plus 2. So right here, x, notice we always put a bracket to hold the position of x because we're going to be replacing x. What did the function say? It says x squared plus 2. So here is where x would have been. I should square that and add 2. Since I'm going to be replacing x with the g function, I go for the g function and I'm putting the g function 4x plus 1. Now, remember I said that we always aim to expand and simplify. So here we have. Now, I want you to notice what took place here. This is 4x plus 1 squared. The entire expression is squared, which means that the bracket is multiplying itself. So the expression of 4x plus 1 is multiplying itself 4x plus 1. This requires what we consider to be binomial expansion. We're using two terms to expand on this term here, right? Two terms. So we're saying 4x will multiply 4x plus 1, and positive 1 will also multiply 4x plus 1. So we're going to take it one at a time. I'm starting here. So the 4x will multiply 4x plus 1. So that will give me 16x squared. The 4x will also multiply 1, and that will give me 4x. I'll move on to the next one. Remember, it's binomial, so it's both of them. 1 will multiply 4x, and that will give me 4x again. And 1 will multiply 1, and that will give me 1. Remember now that we had a plus 2 outside, so I'll add that back. I'm going to simplify. These two are like terms. So the 16x squared will remain, plus 4x and 4x will give me 8x, not x squared because we're adding. So 4x and another 4x will give me 8x, plus 1 plus 2 will give me 3. This is the simplest it can go because all three terms are not alike. This is squared, this is not, and that's a constant. So the expression of f of g of x will become this expression, which we can then state that when you write the composition of a function, the order in which you write them makes a difference, because notice here, g of f of x and f of g of x did not result into the same expression.